Hi, in this video we want to talk about the amplitude and period of our trig functions, and we're going to be using y is equal to sine x as our example. So if I were to draw a standard y is equal to sine x function, that would look something like this, where we start off at 0 and end off at 180 degrees. But this function currently has a coefficient of 1. So in other words, if we were to rewrite this in terms of variables, that would be a sine x, like that. Now what does the a here stand for? Well, the a stands for the amplitude. How high above the point of equilibrium and how low up below the point of equilibrium does your function reach? In this case, it will be 1 above and 1 below. Now, what would happen if we were to change this such that we have y is equal to 2 sine x? Then that means our amplitude would double. And I would need to adjust my axes for that. So something like this. That means we will see our graph rising up to 2 and exhibiting a similar pattern at the bottom, like that. So again, it goes from 0 to, well, this is in 180, forgive me for that. This is supposed to be 360 because that's how long it takes. I was already thinking about periods, but this will be 360. Therefore, we can see that our amplitude has changed. The point of rest, this was 1, this was minus 1, but now we see that it has now become 2 and minus 2. We can also answer the question, what would happen if I were to have y is equal to minus sine x? Well, if you watch the lecture or the video rather on reflections, then you would understand that we are basically making the y negative, and whenever we do that, we exhibit a reflection about the x-axis because we're multiplying the entire thing, which is the y, by -1. Therefore, our function would look similar to the green one, except in the opposite direction. So that's what our function would look like. Same period, same everything, but in the opposite direction. And again, you can influence this. So you could also have y is equals to minus 2 sine x. Again, this would look similar to this one, except we don't start by rising, we start by falling like this. But then it would be a mirror image of the function that we have already drawn on here. So these are the effects of the amplitude of a trig function. Now, what about the period? Well, as far as we are concerned, the period of a sine graph, a normal sine graph, is 360 degrees, which means it takes 360 degrees for it to complete one cycle. Let's draw something better, like that. So it takes about 360 degrees. Let me just draw a proper one, even if it's smaller. So like that. It takes about 360 degrees to complete one cycle on a trig function. On a trig function that is sine and cos, not tan. Therefore, how can we influence the period? How can we make it such that the period is shorter or that it's longer? Well, this one is currently 360, but that's just because our coefficient is 1. Now, in order to get the period of a function, we refer to the base formula. At this point, we are going to call it y is equals to a, first of all, which is the amplitude, sine, and then we're going to have a value in here, which is b, before we put our x. So b is a coefficient for x. Let me put that again. We have b, x. B is a coefficient that affects our period. How does it do that? Well, it will be equal to period will be 360 divided by b. This is only for sine and cos. If it was tan, we'd say 180 divided by b. Then what we want to do is see how this affects it. So what if we were to draw y is equal to sine 2x? Well, the period for this function would be equal to 360 divided by 2, which means it will be 180. Therefore, it means we should complete our function in half the time that it usually takes, which means by 180 degrees, we should have one complete cycle of our function without changing anything else. So our function would then look something like this. So we see it's the same function, but now we've reduced the period. The period is now 180 degrees. And then you might also be thinking, how can we make it such that the period is longer? Well, if multiplying does this to our, so this is y is equal to sine 2x, what would we get if we were to draw y? Let's make that thicker. If we were to draw y is equal to sine x over 2. Well, in this case, b is 1 over 2. So b is equal to 1 over 2. Therefore, the period will be 360 divided by a half, which would give us 720, which just means it should take us this amount of time, or twice the amount of time it would normally take for us to complete one cycle of our function. So let's just say from here 0 to there 720. So our function would look something like this. Still a sine function ending at 720 here. So this is how our period is affected, and it would be the same thing if we were to use a cos function. It would be the same thing if we were to use a tan function. Would move every single point such that it fits into a smaller range. That means every point, every x value that corresponded to a certain y value, we now divide that by 2. So basically, if our function was 0 at 180, then it's going to be 0 at 90 rather than 180. So it helps to understand what the normal function looks like, such that if you're given an alteration, you can just think, what do I have to change about the original to get the one that they want now? What changes or additions should I make? And that would be the amplitude and period on trig functions.